Hello everyone, good evening. My name is Pradeep Raghu and we'll be talking about our subject surveying here. Okay, we'll be talking about our subject surveying here. We'll first look at the syllabus of our subject. We'll look at the weightage of our subject and later on we'll look into the some previous year questions and some analysis we'll do. Okay, yes. So let us start. We'll start first with the syllabus of our examination. Okay. So if you look at this, this is the entire syllabus of the subject surveying. So as you can see, right, the first part of the subject involves the classifications of surveys. What are the different classifications of surveying? Okay, that is the first discussion. Right, so there are different classifications. Okay, classifications based on the instruments used, chain survey, compass survey, like that we have, as well as classification based on the purpose of surveys also there. Mostly the second one is important for us. There are some, some 16 definitions that we need to look at. Every year in your APPSC, TSPSC examinations, right, we get one or two questions, from this particular classifications of survey. Next, various methodologies are also mentioned. Instruments and use are also mentioned here. Okay, the instruments used in surveying are basically chain surveying for horizontal distance, compass for measuring horizontal angles, levels for measuring vertical distance, theodolite for measuring vertical angles. Please remember, our entire surveying basically consists of 4 basic measurements, correct? Horizontal distance, right? Vertical distance, horizontal angle, vertical angles. Okay, right. So instruments used to measure are also very, very important. Okay. Now you see analysis of measurements of distances. So when they are mentioning about distances, it mostly comes under our chain surveying only. One of the recently completed examinations of TSPSC also, if you see, so many questions were there in the single examination, from the types of chains, right? Arrange the different chains based upon their increasing length of link. Okay, what is the link value of each chain, right? Arrange them in the increasing order, in the decreasing order, like that. So many questions came. Yes. Right, now they are talking about elevation here. Elevation is nothing but vertical distance, very important topic for us. And directions. Directions means basically nothing but our angles. Right, now this is one extra topic that they have mentioned here, that is known as field astronomy. That is known as field astronomy. Generally, this field astronomy is there for our APPSC students. In our APPSC syllabus, this particular examination is mentioned. Okay, now generally we don't get too many questions from this field astronomy topic in APPSC. Right. Next, we have a global positioning system, GPS. That is also a present-day advanced surveying technique there. Okay. Next, preparation of map is also mentioned. Next, photogrammetry is also, right, one of a very important topic for us. Okay. Photograph means photo. Metry here means measurement. So for photograph, what kind of measurements we'll take? Mostly in photogrammetry, as far as our PSC level examination, State Service Commission examination is concerned, we get questions from a scale, a relief displacement. Scale, concept of scale in a photograph, a relief displacement. Okay, these are 2 areas from which they will generally ask most of the questions. Now after that, numericals, after that, theoretical questions will come from, some few definitions which are there in our photogrammetry. Followed by remote sensing, which is one of the most advanced topics that we have in our surveying, one of the most emerging, right, topic in our surveying, remote sensing. Followed by, you can read here, survey layout for culverts, canals, bridges, roads and railway alignments, and buildings, setting out of curves. Buildings, right, first they are talking about the setting out of all these engineering works, like, culverts, canals, bridges, road, railway alignments, as well as buildings. Finally, they are asking for setting out of curves also. Right. One topic that they have not mentioned here exclusively is the concept of errors. Okay. But we will discuss that while we are discussing the basics of our first chapter here, that is our basic concept, where we will discuss about the concept of error and all. Also, there are some previous year questions from which they have, asked regarding the propagation of errors also. That is a separate chapter for us. So this is the general syllabus of our examination. Now let us look into the weightage of the examination in some quite few years back. 2015 paper we have analyzed, 18 and 18 papers also analyzed. Transco as well as SPDCL is also analyzed. So in 2015 we got around 4 questions from surveying. 2018 AE around 5 questions came, And in 2018 SPDCL examination, around 7 marks weightage came. So this is roughly around the weightage of our subject. So around, you can see that 4, 5, 7, it is increasing as the years are passing by. So you can expect some good number of questions from this topic. Around you can around 6 to 8 marks you can expect from survey. No too many confusing questions will come, definitely. Whatever numericals are coming, you can solve within 30 seconds without using your calc also. Okay, theoretical questions will be very direct questions only will come. You read the question immediately, you can take the answer. Okay, yes. So that speed and all we have to develop. Okay. Now we will see some previous year questions from this particular topic here. Please read this question. In order to determine the natural features such as valleys, rivers, lakes, etc., the surveying preferred is dash. So this is what I told you initially. The classification of surveying, right, is a very, very important topic as far as our PSC examination is concerned. Every year we get a question like this. 1 or 2 questions you can expect from this particular area. Yes. So let us look at this. What is the purpose of city surveying? What is the purpose of city surveying? If you know the answer to this question, please put that in your comment box. Okay. What are city surveys used for? City surveys are mostly used for urban planning. When you are going to plan out a new city and all, for that we need this particular city surveying to be done, right, initially. Location surveys are mostly used for establishing the locations of details on the ground. Basically, we are trying to set out some engineering structure onto the ground. That process is known as location survey. You can call it like that. Next, cadastral surveys. Cadastral surveys are mostly used for establishing legal boundaries. Right? For establishing the legal boundaries between properties, we will conduct our cadastral surveys, followed by topographical surveys, which are used to determine the natural features such as valleys, rivers, lakes, etc. are preferred. Okay. So here our answer is nothing but topographical survey. I can see that quite a few answers have came here. Yes. Yeah. Okay. Yes. Thank you. Next step. If the back bearing of a line is 36 degree 15 minutes, its forebearing will be dash. Okay. If the back bearing of a line is 36 degree 15 minutes, what is its forebearing? This is one of the fundamental understanding of our compass surveying. What is the relation between back bearing and forebearing? Back bearing of a line is equal to forebearing of the same line plus or minus 180 degree. Okay. So we have to see, right, what the back bearing is. Forebearing is given to you. Oh, sorry, back bearing is given to you. They are asking you for the forebearing. So please understand the difference between forebearing and back bearing is always equal to 180 degree. If your value is less than, right, 180, you add 180 degrees to it. If the value is, right, more than 180, you reduce, right, 180 degree from it. So in this case, it is 36 degree 15 minutes. The back bearing of this line is equal to 36 degrees 15 minutes. So tell me, what will be the forebearing? What will be the forebearing? 36 degree 15 minutes plus 180 degree, na? Yes. What is the answer for this? Yes. What is the answer? You see, 15 minutes will come. Yes. Right. 6 degrees will come. Right. And what is the answer? Yeah, 216 degree 15 minutes. So 216 degree 15 minutes, that is the answer. Okay, that's it. Okay, very easily you can solve. Within less than 30 seconds, you can find the answer here. Yes. So, yes, Yugandhar Sai, very good. That is correct. Yes. Next. A mosque is situated on the far side of a river and it is inaccessible. It can be located by, see, by looking at this option, radiation, traversing, intersection and resection, you should understand this question is coming from plane table surveying. Okay, so these methods are nothing but the different ways in which we conduct our plane table surveying. Method of resection, method of radiation, etc. So we have clearly mentioned the field condition for taking each and every one of this particular survey. So you see, here the condition is that you are having a river. River means what is possible? Intervisibility is there, yes or no? Absolutely yes. Standing on one side of the river, you can see the other side, yes. So intervisibility is there, but what is not there? Accessibility is not there, which means I cannot put a chain through that particular river, yes or no? Yes. So when the points are points to be surveyed are intervisible but inaccessible, the method of plane table surveying adopted is always intersection method. Method of surveying always adopted is intersection method. When will I go for radiation method, sir? Let us talk about that. Please remember, I will go for radiation method only when the points to be surveyed are intervisible as well as accessible, right, from a single instrument station. All the points to be surveyed are visible to me and accessible to me from where? From one single instrument station. Then only I need to go for radiation method. But if you have to shift, we will not call it as a radiation method. Okay, yes. Now, when do I go for resection? See, resection is actually completely different from the first three methods. The first three methods basically tries to plot details from a known instrument station. Okay, instrument station will be known to you. From that known instrument station, you try and find out the details present in the ground. But resection is completely opposite of that. So here, details are present in my paper. With respect to that detail, what you need to find out? Instrument station you need to find out. So resection is the process of finding the station occupied by the plane table with respect to details which are already plotted in our map or plan. Let me give you a small example. So imagine you are having a map. This map is some 15 years ago. This map is some 15 years old. It is made 15 years ago. So now your office is asking, whatever new details came around this particular area, you please go and plot it. What you can do is, you can take this map, go to the field. Whatever details that are present in the map, you identify them in the field. Now you need to orient this particular map with respect to the details you have now. Yes. For that, you take a station in the field. With respect to that station and these details, you orient the plane table. You have your new instrument station on the paper. With respect to this, you can add in the details required. Understand? So that is resection. Traversing is generally done to obtain a traverse. It can be an open traverse, it can be a closed traverse. Whatever traverse you have in the field, you obtain it in your paper by doing traversing. Right, so these four method field conditions you please remember. Yes. Let us move on to the next question. The standard deviation of an observation is plus or minus 10 meter, the probable error would be. So this is one, a slightly advanced topic, right, in our syllabus. Okay, this is about propagation of errors. Right, this is about how a probable error is, propagating to our measurements. Okay, so here there is one standard equation for us. The equation for probable error goes like this. Right, the probable error for a single observation, is plus or minus 0.6745 sigma. This is our equation. Now, what is meant by this plus or minus 10 meter? That is standard deviation. That is what we represent by sigma. Okay, so you see, you substitute that value here, plus or minus 0.06745 times 10 meters. Plus or minus I've already represented here. Right, so if you multiply this, you will get the answer as made one mistake here. Okay, right, this is not there. Yes, 0.6745 times sigma. So if you multiply this, what is the answer you are going to get? You will get the answer as, you see, 6.745 meters. Get the answer as 6.745 meters. What is the answer? 6.745 meters. Option C. Yes. Okay. Sweetie is given option C. I think that is for the previous question. Anyway, that's correct. Let us try another question here. Convert the following whole circle bearings to quadrantal bearings. So they are saying to convert WCB to what? Reduced bearings. What is the WCB given to you? The WCB, the whole circle bearing, is given to you as, right, 170 degree 12 minutes. Now, how do you convert it? I will tell you the easiest method of doing this. Right. Now, what I will do is, I will represent this given data. So you see, right, what is the definition of whole circle bearing? It is the angle measured from the north end of the reference meridian in clockwise direction. You measure from the north end in the clockwise direction. So if you measure from north end in the clockwise direction, what is the angle I am getting? 170 degrees and 12 minutes. Okay, so how is my line lying? You see, my line will lie here. This is how my line is going to lie. Now please tell me, what is this quadrant here? What is this? If this is north, what is this? This is south. And what is this? This is east. So where does the line lies? The line lies in the southeast quadrant. Look at your options. How many options are there with southeast as answer? How many options are there? Only one option is there where southeast is coming. That is the answer. That is your answer. But what if there was one more option with southeast there? Then you have to do your calculation. So if this is the whole circle bearing, the reduced bearing will be what? The reduced bearing will be this much. This will be your reduced bearing here. So what is the value of this theta? This theta will be 180 minus 170 degree, 12 minutes. So 180 degree minus 170 degrees and 12 minutes. Okay. So tell me, to 12 minutes, if I add 8 minutes, how much will I get? To 12 minutes, if I add 8 minutes, I will get, how much will I get? I'll get 20 minutes. 20 minutes, you add 40. I'll get 60 minutes, which is 1 degree, which means 71 degree. 71 degree plus 9 degree is what? Is 180 degree. Correct now? Yes. So 9 degree 48. Which quadrant? Southeast. So southeast will come like this. Okay. So again, we are getting the same answer. So these two procedures you should know, right? Draw the figure, try to represent, look for the quadrant, identify it. If there is more than one similar quadrant, you use the equations like this. Okay. If the line is in this quadrant, right? If the line is in this quadrant, this is your reduced bearing. Okay. If the line is in this quadrant, this is your reduced bearing. If the line is in this quadrant, this is your reduced bearing. Okay. Right. That's it. Let us try the next problem here. Yes, so many people have given me the correct answer. Very good. Right, next step. In the raster data model, features on Earth are represented as. So this is a question from GIS. So GIS has two data format. They are raster as well as vector. So in raster data format, what happens? In the raster data format, what happens? Right here, the data is represented as cell-like structures. So if this is the area to be represented, they will divide that area into number of square grid like this. When we'll divide it into number of square grids like this. And in this particular area, if there is a river that is flowing something like this, how this river will be represented? In whichever grid there is a river, there is one portion of river, that entire grid will be identified as a river. So this is river. This is river. You see one small corner, we are having a river. So here also they will identify as rivers. Again, this entire thing is identified as river. This entire thing is identified as river. What about this? This entire thing is also identified as river. This is also river. One small corner is there. This is also identified as river. This is also identified as river. Right. So this is how the river is identified in your raster format. In which format? Raster format. Now tell me, right, if I show you this and if I tell you that this is a river, will you believe me? Nobody will believe, because it does not look like a river for us. Correct now? So tell me, does it have more resolution, more clarity in what it is representing, or less clarity in what is it representing? It is having less clarity only. Okay, so resolutions are less in our raster format. But if you go with the vector format, right? In vector data representation, we are going to represent our points by using some series of points or some series of vertices of points. Which means if there is a point, like for example a fire hydrant is there, it will be represented as x1, y1. If there is a river flowing like this, it will be identified as a function of x, y. So now it is much more easier to identify this as a river or a road or a canal. Understand? So much more accuracy, much more clarity, resolution is there with our vector data. Okay. So what is the answer here? We can say that it is square cells. So you see, this point representation is with vector. Point representation is with vector. This line representation is with a vector. Where does polygons come? If I want to represent a pond or a forested area, I can go with this polygon representation. Okay. So these three are associated with the raster. This is associated with our vector. Yes. Let us move forward. Yes, this is a question from our photogrammetry. An aerial camera has a focal length of 35 mm. The altitude of the plane is 800 meters above the sea level, the aircraft, 800 meters above sea level, and the average ground elevation above sea level is 100 meters. Find the scale of the map. So here there is one fundamental equations that you should know. It goes something like this. The scale of the photograph is calculated as focal length of the camera divided by flying height minus ground elevation. So what is the focal length of the camera given? You see it is 35 mm divided by what is flying height given to you? 800 meters minus ground elevation is what? 100 meters. So if you solve this, you will get the answer as 35 mm divided by what? 700 meters. But we need to convert this into a ratio, right? So we'll convert the denominator into mm. So 35 mm divided by 700 into 1000 mm. So if you observe here, what happens? This particular mm will get cancelled. 35 and 70 will go 2 times. So 20 into 2000 is there. So 20 into 1000. So 20 followed by 1, 2, 3. That is your answer. So the scale of plotting is 1 in 20,000. Do we have an option? Yes, there is only one option. That is option D, okay? So here the answer should be what? Option D. 32B. Yeah, so I hope you got the answer there. Yes. Here the answer should be what? This one only, okay? So this is, they have printed it as A actually, it is D only, okay? Right, very good. Let us move on to the next question. Yes. The sum of exterior angle in a closed traverse is equal to having n sides is equal to dash. So observe this, we are having a closed traverse. So this is our closed traverse, A, B, C, D and E. What are the exterior angles? Tell me. Exterior angles are the ones that are lying outside my traverse. If it is inside, it is interior. If it is outside, it is exterior. What is the sum of the exterior angle will be equal to? 2n plus 4 into 90 degree. That is the correct answer. 2n plus 4 into 90 degree. That is the sum of exterior angles. Do we have an option? Yes. 2n plus 4 into 90 degree. Answer A is correct. Instead of exterior angle, if they ask you for interior angle, what is the interior angle? This is your interior angle. These are all interior angles. Then the answer would be 2n minus 4 into 90 degree. What if they are asking you for deflection angles, sum of deflection angles? So what is this deflection angle, sir? Let us see. So you see, I am having a closed traverse like this. Okay, I am having a closed traverse like this. Now, if I extend this line here, this is A, B, C. This is the deflection angle at B towards C. This is the deflection angle right at C towards D, delta C. This is the deflection angle at D. This is the deflection angle at D from D to E. And this is the deflection angle at E from E to A. And this is the deflection angle at A from A to B. So my question is, what is delta A plus delta B plus delta C plus delta D plus delta E? Please remember, the summation of all these deflection angle is always equal to 360 degree. Correct now? Chudu, delta A plus delta B plus delta C plus delta D plus delta E. I am coming back to the starting position. A plus B plus C plus D plus E. What is the sum? 360 degree. So here, whatever be the sides, whether there are 10 sides or 100 sides, the sum is always equal to 360 degree. Okay. So this option C is correct only for deflection angle. This is correct only for exterior angle. This is correct only for interior angle. Okay, na? Yes. Right. Next. EMR in remote sensing is known as. What is remote sensing? Remote sensing is the process of measuring or collecting the electromagnetic radiations which are either reflected by the object or emitted by the object. Okay, emitted by the object. So if you look at your notebook, in your notebook you can see that there is blue color ink. because that blue coloring is reflecting blue light into your eyes. Your eyes is collecting that blue light and you understand that that color is blue. Right, so that is the idea. If I emit a blue light in a dark room, if I turn on a blue light, you can see that as blue. Why? Because it is emitting blue light. From your notebook, it is reflecting. So the process of capturing this reflected or emitted energy is what we call it as remote sensing. Now what does EMR stands for? Electromagnetic radiation. What is the answer? Electromagnetic radiation. Okay. Right, so example of an electromagnetic radiation is nothing but your visible light. Yes. Next up, the minimum number of GPS satellites are to be tracked for getting a position is, remember the answer is always 4. The answer is always 4 are there. Okay, yes. Next up, the curvature correction is 5 times refraction correction, 7 times refraction correction, 8 times refraction corrections and 9 times refraction correction. So they are asking you for the relation. Please remember the correction for refraction is numerically equal to 1/7 of correction for curvature. So from this, what is the correction for curvature is equal to 7 times correction for refraction. Is equal to 7 times the correction for refraction. What is the answer? Option B is the correct answer. Yes. Okay, so very important discussion in our leveling chapter. The length of backward tangent of a circular curve in terms of radius and external deflection angle of D is dash. So tell me what is the tangent length? T1I is equal to IT2 is equal to R tan delta by 2. Here delta is given as D. So what is this tangent length, sir? What do you mean by this tangent length? So please observe this. When two lines are intersecting like this at this point I, we cannot ask our vehicle to travel a path like this because your overall velocity, your side distances, they are practically 0 here at this junction. So rather than changing at 90 degrees like this, we expect the vehicle to enter into a curve like this and change direction. So this is T1, right? This is T2. So the tangents here are T1I and IT2. The external deflection angle here is D. If the curve is having a radius of R, how these are related? These are related by using the formula. T1I is equal to IT2 is equal to how much? Is equal to R tan D degrees by 2. R tan D degrees by 2. That is your answer. Okay, so here what is the answer? R tan D degree by 2. This 2R sine delta by 2, what is this? This is the length of long chord. 2R sine delta by 2 is the length of long chord. Okay, that's it. So none of these are used anywhere else. Okay, yes. Next step. Spectral reflectance of a wave is computed using spectral reflectance curve we'll make. Okay, so to identify an object in the in anywhere in the space or in the earth, or if you go to moon or if you go to Mars, to identify an object without being actually be there, we use this spectral reflectance curve. Okay, which is nothing but a plot between reflected and incident energy. So plot between reflected energy and the incident energy. That's it. So here the answer should be D. We have discussed this in our lecture series. Yes or no? Yes. Okay, so that's it, guys. So these are some previous year questions from our examination. So I hope you enjoyed the session. Okay, I hope you watched the videos very thoroughly and refer the materials that we have prepared. You should be able to crack it. This is not a very difficult examination. Please understand, PSC examinations are not a difficult examination. It is about those students who have practiced very well. That's it. Okay, with limited time, how many questions you can answer correctly. So your job as a student is to go through the syllabus as soon as possible and familiarize with as many number of problems as possible. Expose yourself with as many number of problems as possible. If your preparation is very thorough, most of the questions will be the ones that you have already practiced. Okay, don't think that going through the one set of question is enough, one time is enough, not really. Okay, you make sure that you are going through our classroom practice questions, our test series and all repeatedly to familiarize with the different types of questions. Okay, most of the questions you should be able to answer in less than 10 or 15 or maximum up to 20 seconds. Don't spend more time other than that. Okay, yes, so thank you guys, all the very best, good night.